Okay, so the purpose of this video is to explain why a sine wave looks the way that it does when we graph it. Okay, so we're going to be looking at the function sine of x here. So we have y equals sine of x. And just as a quick note before we get started, when you're talking about this, the inputs here, in case we've forgotten, the inputs, the numbers that I'm plugging in here, these are angles. Okay, now y always indicates our output. The output of a sine function for what we're going to be looking at here today, these are the y coordinates of the points that are on the unit circle. Okay, so I'm going to jump over here real quick and I'm just going to create a table of x and y values, right? Inputs and outputs. The first input that I'm going to use, you can see, if you look at the scale of the graph here, okay, we've got the x-axis and the y-axis. Along the x-axis, we've got these tick marks labeled. This is our scale right here. So when we're graphing trig functions, we don't use a scale of 1, 2, 3, 4, 5 down here. We use pi values because pi values are angle measurements. So these are our inputs and our outputs are going to go up here. Okay. So the angles that we're going to focus on, and we should know most of the angles that are on the unit circle, but we're just going to look at the most basic ones we can, which are these axis angles. So we're going to look at 0 radians here. We're going to look at pi over 2. We're going to look at pi, 3 pi over 2, and 2 pi over 2, which is over here. Okay, so we're going to start with 0. If I put a 0 here, right, the angle that is 0 radians, the y coordinate of the angle that has 0 radians is 0. And that gives us our first point, which is right down here. The next angle I'm going to use is pi over 2. Pi over 2 is right here. So that input, pi over 2, is going in here. And to calculate the sine of pi over 2, we find the y coordinate at pi over 2, which is 1. So at pi over 2, we have an output of 1. That means from here, we'll make this 1 right here. Okay, we'll spread this out a little bit. Then we move to pi. The y coordinate at pi is 0. Then we move around to 3 pi over 2. Here's 3 pi over 2. At 3 pi over 2 radians, the y coordinate is -1. So again, I'm taking this, I'm putting it in here. The sine of 3 pi over 2 is the y coordinate at 3 pi over 2, which is -1. And then lastly, we use 2 pi, and we're going to get the same answer we got up here. So we have 0, 0 as a point. We have the point pi over 2, comma 1, which is here. We have pi 0, which is here. 3 pi over 2, -1. I'm going to have to slide this down a little bit. Let's go about right here. There's -1. That would go here. And then we have 2 pi. Now, without getting into too much detail about the rest of this, okay, so the wave that we use to connect these points is based on the y coordinates that are around the unit circle. Okay, so I don't want to get too detailed here, but we really don't want to aim right at this point, right? Because if we aim right at this point, we're talking about a constant rate of change. This is not a line, okay? We are not changing at a constant rate as we move up here. The y coordinates are getting very high quickly, and then as we approach pi over 2, the y coordinates are not increasing that quickly anymore, so we start to flatten out. What that looks like is from here, instead of going straight to that point, we kind of want to bring it up and then bend it as we get towards that. We're not perfect here, okay? But you want to have something that looks like, these are called sinusoidal waves. So you want to have something that resembles a wave as we go from point to point through here, okay? Now after this, okay, we talk about these functions, and these functions are called periodic functions. The reason we call them periodic functions is because they have defined periods, which are a length on the x-axis or an interval on the x-axis over which the unique y values are covered. So if we started here, which was 0 radians, and we ended at 2 pi, what would happen if we kept going around the unit circle? We've basically covered all of these angles here, okay? Everything from 0 to 2 pi. But we've talked about in class, we can keep going. And if we keep going, we keep getting bigger and bigger angles, right? But the coordinates of those angles just keep repeating from what we already saw. So basically what we see, thank you. So basically what we see after a while is you could take this wave, and I'm drawing it very crudely right now, but you'll get the idea. You could take this wave, and what happens is it basically repeats in this direction and in this direction because the period is 2 pi. So every time we move 2 pi radians, we're going to see the exact same behavior. We're going to see the exact same behavior over and over and over again.